1 hour. So regarding the way of questioning, as you may know, you can submit the questions on the public chat function on the left side, which then can be addressed by a presenter. So if you have any question, you can write down the question in the chat function. Thank you. So, Professor, the floor is yours.
Okay, thanks, Saman, for the introduction, and hello, everybody. Thanks for attending since the beginning. We see that we have some ESRs that are still missing. Hopefully, they will be joining. Okay, I hope that you can hear my voice well and loudly. And in case it's not, please stop me, because otherwise I'll be speaking to my PC without any interaction. Okay, so let me start with a preliminary assertion. Well, despite in the title of this OSC, there is no any QoE-aware internet architecture, probably not yet. The reason is that it is very difficult to bring from the application level the QoE models to evaluate the perception of quality from the user perspective into the network. So currently there are important key requirements about bringing to the network layer the QoE evaluation and assessment to optimize the network management. But still there is no any QoE-aware internet architecture, at least if we talk about standardizing reference architectures or some reference architectures that are accepted by the industrial and scientific community. So there are requirements, and hopefully they will be met in the near future. Anyway, it also represents a green field for us, because I mean there is need for smart approach to bring into the network these QoE models and to plug and play this model and be able to really manage the network, taking care of the quality experience perceived by the customers. So the outline of this presentation is about an introduction on internet architecture. Then I will talk about two different approaches for the management of QoE at the network layer and at the application layer. And then we talk about joint management at both network and application levels. Then about SDN and NFV, and which are the future challenge. So let me start by describing what is the chain of actors that are involved in the deployment of services and delivery of service to the final users. If you see in this picture, on top of this picture, we have the application service providers, which are those that we generally refer to with over-the-top service providers. And those are actors like YouTube, Netflix, and Apple, Amazon, and others. Those are the ones that provide the service to the final users using content provided by other providers. Then we have also the application providers. The application providers are those that are just providing the software and applications that are installed in the user terminal, but they are not dealing with the management of the service while the services are used by the customer. They're just providing tools and applications. Then these over-the-top service providers are interfacing with the ISP, which are in the core of the internet and network providers through the network access facilities. They have some agreements, they have some peering agreements through these network access facilities. And the ISP are those that are just sending bits from one part of the network to another part of the network, then delivering bits transferred from one point to another with some quality of service requirements and targets. Well, the end user are finally access to the internet through the network access facility with all the different technologies that are used for the last miles, either wireless or wireline technologies. Well, we know that there is this trend of big amount of video, multimedia content that is delivered over this network. There is a very famous publication from Cisco about the fact that soon 80% of the traffic will be video. But there are also new trends that we should consider whenever we deal with network management. And one trend is that an increasing, quickly increasing amount of traffic is given by data-centric network. It means that an increasing share of this traffic is given by the transfer of backups from one data center to another, image of virtual machines from one data center to another, as well also data that are cached in different parts of the network. Well, we also have to consider that 80% of this traffic is internal. It means that typically it doesn't affect the quality of experience of the final user because the user is not directly involved in this. I mean, it's not impacted, it's not affected by this traffic. Well, the other trend is given by the IoT applications, which are more and more deployed in the internet. IoT application, we're talking about smart cities, smart houses, smart transports. These applications are good that generate a few amount of data, so a small number of packets, and so the data is not really intensive. We are not talking about big amount of traffic like 1 megabit per second like for the videos. We are talking about few bit per second, and but still they impact the quality experience of the final user. If we think about the management of the comfort in your house, or if you think about applications that are used by the citizen or tourists to move in the urban environment. Okay, if you look at the tools that the ISP have in their hands to manage the quality of service and then impact on the quality of experience, then we know that there are different standards that have been defined among 10 years ago. So we are still using the tools that have been defined in the past 10 years. More than 10 years ago, and well, one reference standard recommendation that we can consider for the quality of service tools available by the ISP, we can refer to the ITU Y1291, which is present in this slide. So these are the tools that actually the ISP are still using for the management of the quality of service in the network. And we see that these tools are divided into data plane and control plane. So the data plane is the plane where the traffic, the traffic of the user is passing through. So the packets of the user are managed by all these tools that are here in the data plane. So the ISP can shape the traffic, make some marking of the packets, classify the traffic depending on which application is generating the traffic. They can avoid congestion by reducing the traffic coming from one given source, for example. They can implement different traffic policies that have different impact, especially on the queuing of packets through the egress links of the router. So these are the tools that still the ISP is using to manage the quality service. And again, these tools have an impact in the influencing factor, the system influencing factors. Well, the control plane, we have the tools that actually this is a sort of brain of the router, and here the brain decides whether to admit one new flow of traffic or not. So the flow coming from a new user or new application, whether to reserve some resources along the path to get to the destination in the network, or which kind of policies should be used for routing, and the routing will have an impact on the quality of service that will be provided to the flows that are routed along this path. Well, we also have the management plane. The management plane is here the tools for metering and recording the traffic are implementing. We have the general rules for the policies applied by the ISP, tools to restore the traffic in the network in case of some issues in the network, and then the tools for the definition of service level agreements. Okay, I'm not going into the details, just reminding the tools that still the ISP has on its end to manage the quality of service in the network. Okay, and the ASP as a network which is divided typically into the P backbone, the core of the network, where we have high-speed routers and links with high capacity, and then we have the Ethernet LAN and the other access networks. So, for example, here we have the wireless access network, and these are the most let's say important part of the network, because here you may have the bottlenecks, and usually these are the parts of the network that affect the quality of service and then the quality of experience for the final user. Okay, if we look at the OTT service providers, they do have some. They manage the services and the applications typically in cloud computing facilities. They have usually virtual data centers, which are made by several virtual machine clusters of virtual machines, where they implement the applications that are provided to the final user. So the final user then will be receiving the traffic through the P backbone, traffic generated and provided by the clusters of virtual machines where the application of the OTT provider are deployed. Well, which are the tools that the OTT has on its end? Different from the ASP, the OTT cannot affect the delays, the overall delays of the network, the packet losses, and the jitter. But the OTT can control the rate at which the content is encoded and transmitted to the final user. The OTT may decide in which location of the network the data will be sent to the final user. So the place where the data is cached and stored, and so to reduce the delay and reactivity of the application which is used by the user. Well, it can provide also additional functionality. We know that it's important if the service is augmented with some, for example, interactive features or with social features or some additional feature which may impact on the quality perceived by the final user. And we know that there are some other application level parameters like the playout delay, which in case, for example, of interactive communication is really important. We know, for example, in VoIP, communications, but also in PTV, but also we know the playout delay in dash streaming is also important, even if not that much as in VoIP communication. So these are the tools that can be, these are the parameters that can be well controlled by the OTT. Then if we restrict our attention to the OTT and SP, we see that these two guys have a different perspective in the provisioning of the service. Well, the SP are in the bottom in the bottom part of this picture, so they are perceived as providing a commodity. So once this service is perceived as a commodity, I mean the value that the customers give to this service is low. So the issue is that now it's assuming that something that is already, I mean, where the technologies are mature, so they don't expect a lot of change. So this service provided by the SP is perceived as a commodity. And it's an issue for the SP, and the business model is very well defined. It's typically based on a flat rate business model. So the flat rate is the amount that the user pay for the SP. There is a lot of service transparency. There are many tools that can evaluate the quality of service that is provided by the SP, and this brings a very competitive DSP into a very competitive market. And but still, another negative aspect for the DSP is that they have to cover high costs related to the use of the wireline, especially, or to pay for the license for the frequencies that they have to use to get to the final user. On top, we have the over the top. They are deploying different kinds of services and applications. Typically in the cloud, they reach the final user. There is a continuous evolution of the applications provided by the OTT. So it's a very dynamic environment in respect to the one of the ASP. And they have big numbers in the sense that they can reach very huge numbers of customers exploiting the facilities provided by the ISP. So we have to consider this scenario whenever we talk about the management of the network and application and services, and also whenever we want to talk about quality of experience. Because at the end of the day, when we talk about quality of experience in this environment, we are talking about the management of services and applications provided by these two actors in this environment. Okay, let me start then with the major aspects of QoE-based management of services network. We know that the overall process of QoE management is based on three general steps. So the first one is about QoE modeling, and most of you are dealing with modeling. It means creating some objective models that can evaluate or can assess or predict the quality of experience perceived by the final user. Clearly, these models should be models that are designed to be used in the phase of the management of quality experience. Not all the models can be used. We know that there are different kinds of models, and only those, especially the one that are the parametric model or packet models, can be used in this environment. We will talk a little bit about that later. The second step is clearly the QoE monitoring and measurements, which should be done by deploying active, passive probes in the edge or the core of the network, and this may be even virtual or applied to virtual components in the network. Then the third step, which is very important, is the optimization of quality experience and control. What does it mean? I mean, it depends on the objective of the operator. Optimizing QoE probably can result in maximizing the average quality of experience, or it could be reducing the variance of the quality experience over a category of users or over all the users in the network, or reducing the variance of quality experience perceived by different users in different areas of the network. So there may be several objectives. I mean, there is no any one general and generally valid objective when we talk about QoE in the management of the network. Well, we know that it's a very challenging task, and the reason is that the data is, the traffic of the data is always growing, and it may change suddenly. We have an heterogeneity of mobile devices, user with different characteristics and with different profiles, different expectations, and there is the big problem about costs, but because when we talk about, especially when managing a network, well, it's easy to really see costs increasing very quickly if we wanted to introduce a new intelligence system and procedure in the network. Well, as I've introduced at the beginning, there are two major different actors in this environment. We have the network provider, network service providers, and the application providers, so the OTTs and the ISPs. So these have a different perspective. They can control different parameters in the network, and they have different tools for the evaluation of the quality experience. So typically we talk about the quality of experience based in network management for the ISP, and quality of experience based in application management for the OTTs. Okay, when talking about the application management is something that is related to the end-to-end management of quality experience, because the OTT has access to the user terminal and has access to the servers that are providing the service on the other hand of the network. Well, the SP instead is managing the core network and part of the internet and the access network. It may happen that different SP may be providing the data transport service. They may be affecting only one part of the chain that is used to provide the service to the final user. So they have a different perspective. They don't have access to the user terminal usually. They don't provide the services in the application services for the deployment of the service to the final user. Okay, let's talk a little bit more about the network management, the QoE-based network management. Okay, if we talk about the QoE-based network management, and you look at the works that have been proposed in the past, we see that most of the issues are organized into 3 different layers. So we have the data acquisition layer, and it's the layer where the probes are activated in the access and core of the network. This may be active or passive probes, and so the issues that are addressed by this layer are related to the real measurements in the physical devices of some specific metrics. So that could be related to the amount of traffic that is flowing through one interface, the delay from one point to another, or to measure something like packet losses or any other metric that is associated to the service provided by the network. We see here we don't have any probe at the user end device, except for some very special cases. The ISP is only able to monitor the separate access and core network. Well, if you look at the monitoring layer, is the one that is receiving the data from the probes. The traffic is classified. It's important to classify the traffic to know which QoE model to be used. And then once the traffic is classified and the metrics are collected, then the monitor layer is computing the quality of experience level for the service under observation. And well, then the scores are sent to the management layer, and the QoE manager will be deciding whether it's important to introduce some change in the network, depending whether the quality experience measuring the network is satisfactory or not. If there are then some issues, then a certain optimization procedure is implemented in the network, and depending also on the service level agreements for the given services, some actions are introduced in the network. And these actions affect the access network and core network. They cannot affect the configuration of the service of the application servers. And the outcome is typically a change in the classification procedure of the traffic, marking of the packets, dropping, queuing, shaping. Even this may affect even the connection emission control. So some new traffic may be rejected, some new calls. Anyway, these are the typical actions that could be implemented by the ISP in this case. Okay, which are the monitoring parameters? I already mentioned this parameter. We are talking about bandwidth, delay, packet loss, jitter, sometimes also the order of packets. There are also static parameters like the configuration of the service, parameters that are again collected from the routers in the network. Well, the existing QoE objective models, they are meant to identify relationship, to find a relationship between quality of service and quality of experience. Clearly, because at this level we are talking about quality of service, but then when taking decision, we need to find what is the impact of the quality of service provided by the network into the quality of experience. And as I said before, there are important actions that could be introduced in the network. Dynamic network resource provisioning, something that I have not mentioned before. How to perform some handover. It may also impact long-term actions like decision on the network planning for future extensions of the network. Well, we know that there are some important limits in these procedures. One limit is about encryption. We know that more and more the OTTs are encrypting the traffic, so it's difficult to make an accurate classification of the traffic, and it's almost impossible to identify which content is transmitted by the packets observed by the ISP. Well, another important aspect is the overhead due to probing. Well, most of the overhead is due by active probing. We have an overhead in terms of computational complexity that is introduced in the router, in the nodes where the probes are activated, especially for the active probes. But there is also a problem about the overhead in terms of signaling, because these probes need to send sometimes in real time the measurements to the central node that is managing the quality experience. So we may have hundreds, thousands of probes in the network, and these probes may be sending the data to the central node for the management of the network in real time. I mean, it may happen that for some nodes, for some probes, they don't need to send the data in real time. They may store locally and send overnight, for example, but for some important applications, there is the need to send the results of the probing activity in real time to take immediate actions. And this is a problem in this environment. Well, the other limited for the ASP is that they have not access to some important influencing factors, like, for example, the application level parameters, like the buffer occupancy, but they don't even have access to the profile of the user or to the context of the user, which is something that may be detected by the OTT, but not by the ISP. Okay, so we see here in this picture that that the QoE management means at first to collect the measurements from the network through this QoS measure module. Then this module is computing the QoS metrics, which go to the QoE network monitoring based on the models that are selected for the application that is running the network. Then these QoE metrics are sent to the resource management module that is then controlling the edge routers, but also sometimes the core routers in the network. Anyway, hopefully the general framework is clear. It was just a general introduction. What I wanted to do is now to take a look at some of major works that represent the typical and major approach that have been proposed for the QoE-aware network management. Well, this work is proposing this central QoE management entity. We see here on top of this picture, and the central QoE management entity is based on 3 modules: the QoE controller, QoE monitor, and QoE manager. Okay, in all these works, the researchers have called these modules in a different way, but more or less these implement the actions, the activity that they've defined so far. But still, let's look at this, the idea of this work. So the workflow is this one. The QoE controller is the one that is interfacing with the network. So through this arrow 1, they are instructing the network about which probes should be activated in the network. So this data is sent through the other row. So process 2, this data is sent to the QoE controller. So this is the QoE controller is the only one that is interfacing with the network. And then this data is sent to the QoE monitor. So the QoE monitor is actually receiving the outcome of this measurement, and this data is collected by QoE monitor, and the QoE monitor is computing the level of QoE per flow. So this work proposes to monitor each flow in the network and to evaluate the quality experience per flow. So in parallel, the QoE controller is also sending information about the status of the network, the configuration of the network. So on the left-hand side, we have only information about the QoE achieved by the network, and on the right-hand side, the topology and status of the network. Then 4 is about sending the final QoE score. So the models are here. The QoE monitor is using the appropriate models for each one of the applications running in the network. Then the QoE achieved for each application sent to the QoE manager, and the QoE manager may decide to introduce some actions. So the corrective action is here in 5B, which are optional. And in case these should be introduced, then QoE controller is introduced into 6, the relevant commands sent to the network for the change of the service. Well, if you look at the architecture, possible architecture, we see here that here we have the SARS, and in the SARS we may also have some active probes with intrusive signals sent into the network. Here we may have embedded agents which are installed in the terminal. And this is only possible in some cases because the ISP usually has not access to the user terminal, but only in case also the service provided by the ISP, it's possible for it to install these embedded agents in the user terminal. Anyway, most of the monitoring is done by probes installed here in the nodes of the network, of the core network and the access network here. And the models that could be implementing are the packet layer, bitstream, and parametric. We know that we have these different kinds of models. But as I said before, the bitstream is very rare to be used because it's really resource consuming, and the probes would need to access to the payload of the packets, which is something unrealistic in real-time monitoring in the networks of the ISP. Well, we have packet layer models which could be used. The reason is that there are not that very effective, efficient, objective metrics that work at the packet layer. So most of the time, the ISP resort on using parametric models, which are more, as there are standardized parametric models, so they consider some parameters about the configuration of the network, and then based on some on these parameters and some performance metric of the network, like losses and delays and jitter, then they assess the quality experience provided by the network. So these probes are getting information from statistical historic. They are collecting statistical historical information because they also have to predict what would be the behavior in the near future to understand what would be the impact on the quality experience in the near future of the traffic and status of the network. So they also collect information about the service configuration and clearly real-time measurements like delays, losses, and order of packets and other information. Well, we know that we have this problem about the fact that it's often difficult to really understand, classify the traffic because the ISP cannot understand what is sent into these packets, but still, I mean, the authors, for example, this paper, they say that this is a big issue, and then they assume in any case that there are some machine learning techniques that could be able to understand what is the content of the packets, even if the content is encrypted. Okay, let's look at how the performance are evaluated by this kind of work. So in this case, the authors have considered the VoIP service, and they have selected the E-model, so the parametric E-model for the evaluation of the quality experience of the VoIP services. And we know that the E-model is a function of observed delay, packet loss, and they also consider which codec is being used and the robustness of the codec to packet losses. So the performance evaluated in terms of the deviation in the prediction of the quality of experience changing the reporting period. So one of the major parameters they have to decide is how often they have to measure the quality of experience and to ask the probes to collect data from the network. So the I guess the resolution is one measurement every 100 milliseconds. You see here. So this is the lowest interval time interval for the measurements. So every 100 milliseconds. And as far as this interval increases, then there is a reduction in the performance because the deviation increases, as you see here in the blue line. So this gives an idea on which performance indicators and which kind of parameters can be changed in this context and how the performance are evaluated. So it's really important to understand how much of the traffic, how much of the measurement deviate from the reference accuracy. Okay, if we look at the green line here, we see that the green line is measuring the senior overhead. So the higher the number of the smaller this the higher this time interval. So the longer this time interval, the lower the amount of senior overhead generated by these probes. And clearly this is an advantage. So from one side we lose in the accuracy, from the other side we lose in the senior overhead. Okay, so they have implemented which kind of action is taken by this central management entity. Well, one action is the connection admission control, CAC. The network is monitoring the average quality experience for the VoIP connection, and they say, okay, if the average quality is above 3.5, then we do nothing. So the network doesn't introduce any corrective action. But as soon as the quality becomes lower than 3.5, then this entity takes some action, and the action is about refusing additional calls in the network. So you see here you have a certain lag in the reaction of the network. So the network reacts after a given delay. So the network has to understand that something wrong is happening, and then it decides to refuse all the additional calls in the network. And then after a while, the network, the average quality experience then again becomes acceptable and higher than the threshold of 3.5. Okay, in case the network didn't introduce this control and this corrective action, then you see here that the quality would drop till a level of very, very bad quality. Well, they were considering a situation where the services provided in the stadium during a soccer match, and so many calls were set up by the customers in this environment. So there were many users, and for that reason, the network wasn't able to accommodate all the calls coming from these customers. Okay, which are the major issues that are addressing in this scenario? Well, at first, in this proposal, we have always to decide whether to use a distributed centralized approach. So centralized approach is, let's say, more robust, but on the other hand, we do have the need to send all the data collected by the probes has to be sent to the central entity. In a distributed way, I mean, it's more prone to errors in the configuration of the service, but we have a reduction in the amount of traffic that should be managed by the network for the measurements performed by the probes. Clearly, we have to define every time the clear interfaces to collect this data from the probes. Well, the issue is to decide which is the frequency of the measurements to find the optimal frequency for the measurements and the signal overhead. And the issue is that in this kind of works, they don't consider the long-term quality experience. So in this specific example, they are considering the quality experience only for a specific section, so for a VoIP section, but they are not considering the impact on quality experience due to the fact that some calls are refused by the network. So if we have also always to look at the long-term quality experience, which is something that is not considered here in this kind of works, and these are an impact on the customer churn, other than the quality of experience for the specific section. Well, we already said about the problem about the traffic classification and encryption, scalability concerns, because as the number of calls and the number of customers increase, then the number of measurements, since we are doing measurement per call, per flow, So it means that the scalability is a big concern in this case. So this approach should select exactly which calls need to be monitored only if the central entity understands that there may be problems related to these calls. Well, from a less technical perspective, there is a problem on the fact that the QoE does not only depend on a single ISP, but many times the quality experience depends also on the quality provided by the other network operators that are used to convey the packet from the application server to the customer. So sometimes the traffic moves from one network to another network managed by different operators. So it's you may be improving the quality from your perspective, but doesn't mean that the end-to-end quality experience is really improving. Well, we know that we have problems about net neutrality. You introducing this kind of quality of service, quality experience, basic differentiation in the treatment of the traffic. You may, impact on the net neutrality. And also user privacy, the user may not be happy about the fact that you are monitoring each single flow, and so that could be an additional problem. Okay, let me skip this other algorithm. I see that I'm speaking a little bit slow, so let me move to the QoE basic application management. Okay, what we have seen till now is the case of an ESP that have access to that is managing the network and can control the parameters related to the configuration of the network. Well, the OTT, differently, the OTT can implement this application management and somehow the OTT in this case is a mediator between the user interface and the network. So it's in between, and it's closer to the user, the customer. So the activity that is performed by the OTT now is about monitoring network problems. So the OTT can only monitor the status of the network and determine which are the QoE optimization actions that could be performed at the application level, not in the network. So one advantage is that the OTT can take into account also the user preferences and the context. So important influence factors that without these ones, it's really impossible to estimate the quality of experience. So the application provider is really in the position of better evaluating the quality of experience of the customer. Okay, if you look at the framework similar to the one we have seen for the ISP, at the acquisition layer this time we have active probes, active and passive probes only at the network edge, and in this case we may have also QoE agents installed in the user and the device. Okay, this data is sent to the monitor layer, and the QoE models are selected and the appropriate QoE measurements are done, which are then sent to the management layer. And the management layer is performing the optimization and decided which parameters should be changed at the application level, clearly depending on the application policies. And this time, what could be changed is the configuration of the application server and also the actions taken by the client terminal. Okay, let's consider this example. So in this case, the authors have considered the dash services. You know, the dash standard is the one according to which the web server are stored different versions of the same content, which has been coded at different bit rates. So you see here the web server, we have one stream of 1 megabit, 2 megabits, and 5 megabits per second. And here we have the different chunks from 1 to n. So this is already stored in the web server, and the clients are the ones that decide which version of the content should be provided by the web server. So for example, client 1 started from the first chunk code at 1 megabit per second, then switch it to the 2 megabit per second, then to the 5 megabits for the third, fourth, fifth, and sixth chunk. Client 2, which probably has a worse connection, then it starts with 1 megabit per second, and for chunk 1, 2, 3, and then it moves to 2 megabits per second. Okay, the quality of channel improves a little bit, and then it decides to change the quality to something at a big higher bit rate. Okay, you know, client 1 and client 2, they are those that really decide about the quality of experience. I mean, they have a view of the quality experience, and they decide to change one important parameter, which is the bit rate at which the content should be streamed to the network. Okay, in this case, this work considered that the important decisions taken by the clients, and so they have proposed a different approach to decide when to change the bit rate. You know, in case of dash streaming, what is really important? The most important parameter is not to have underruns of the buffer. So the buffer should never starve, because if it starves, it means that the playback is stopped, and it's there is a buffering event, and the quality degrades a lot. So this paper assumes that all the different approaches that have been proposed to control the bit rate selected by the client, all these ones are able to avoid any rebuffering. So they are mostly focused on another parameter that is important for the quality experience in this case, which is the bitrate switching events. So the frequency of the switching of the bitrate selected by the player at the user terminal. And they have worked on proposing a new algorithm, which is named Zara here. And this algorithm is considering the size of each chunk of each segment, and according to the segment, they may decide whether they need to change or not the next the bitrate for the future. So just with this experiments, I just wanted to tell you which are the aspects that are considered now by the current research in deciding, in controlling at the application level the quality experience. So they are trying to reduce the number of switching events for the changing the algorithm that is implemented in the user terminal. And okay, I'm not talking about the other two competitive approach anyway. They are saying that they can better predict what's the status of the buffer in the near future, looking at the size of each single segment of each single chunk, and they are showing that they can reduce the number of switch events. You see here they have only 6 switch events in a given for a given section, and the other two algorithms, TBA and BBA, are having a higher number of switching events. Okay, they are considering different kinds of interruption, short interruption, and long interruption in the transmission channel. The other parameter they are considering is the convergence time, and the convergence time is the time that the application needs to get to the optimal bit rate for the given configuration. And again, they show that they can reach the optimal value of the bit rate, and the convergence time is very low for the SAR algorithm. Okay, I don't want to say, okay, SAR is better than the others. I just wanted to tell you which are the aspects that are considered by the application management approach and when focused on the quality of experience. Okay, this is another algorithm. Actually, it's one of the paper we have been working on. We have worked on in the it was 2-3 years ago. And again, here we have the client, and here we have the server, and the server is streaming content at a given bit rate. So it's actually it's encoding real time this time, different from the dash algorithm. The video is not already encoding at different bit rates, but we have the encoder that could be controlled by the rate controller here at the client. So the client is again the one that is deciding which is the optimal bit rate for this section in real time. And so this bit rate is sent to the server, and it's the one that is used to control the encoding process. So this is performed in real time. So this is a visual quality estimator, and the visual quality estimator is the one that estimates what is the quality changing the bit rate, and clearly the bit rate has an impact on the probability to have losses in the network. Okay, if you look at the workflow. Here we have a model. This is implemented at the client here in the visual quality estimator and rate controller. Okay, these two blocks are the ones that really do the job. So we have the transmission time of observation. So this model is controlling the delays in the transmission of packets and the losses, and this one is controlling the quality of the decoded frames. So the two graphs are generated. One is the quality change in the bit rate, encoding bit rate, when there are no starvations, so no rebuffering. And the other one is the one that measures the quality change in the source coding bit rate in case of starvation. So if you have a starvation, the quality is clearly lower. So why it's important? Because we may have some starvation. We wanted to understand what the expected quality, because if we increase the bit rate, the probability of starvation is higher. Then we wanted to estimate the future quality, changing the bit rate, considering both the cases in case we don't have starvation and the case where we have starvation. And the optimal bit rate is computing in real time, and the bit rate can be changed every 1 second. And this new bit rate is sent to the server, which then will encode for the next 1 second the video and the new bit rate value. Okay, there are not only the approach based on network management and application management, but there are some joint efforts. So it could happen that the operators may join the efforts, and for some reason they can apply the control of both the application parameters and network parameters. Well, it happens most of the time when we have services provided directly by the ISP. It's the case, for example, of voice services. In this case, the ISP has the complete control of the application servers and the network. The other case, the one of the PTV service. It happened in the past when we had the IPTV service over RTCP, RTP protocols. It also happens now that the operators are implementing the dash standard for streaming multimedia content to the final users. It happens in Italy, for example, by Vodafone, TIM, and the other operators. They have their own multimedia TV services deployed by their own infrastructure and delivering the content by their own network. So they have full control of everything from the application server to the customer application. The other case is that OTTs and ISP may decide to collaborate each other. In this case, they may share some information, and sharing information, one may have control of the status of of the service at a given layer, and they can implement a joint effort to manage the quality experience. Okay, so if you look at the diagram or the sketch that we have seen for the other two cases, in this case, at the data acquisition layer, we have active and passive probes in any place in the network, and we also have the user agents that are deployed in the user device. Okay, then we have the monitor layer for the evaluation of the quality experience based on all these parameters that are collected by the data acquisition layer. And at the management layer, we have the one that decides whether some action should be taken. And then in this case, the action should may affect the access network, the core network, application server, and client terminal. So in case of the IPTV service, for example, here the authors have proposed this infrastructure. You see here that the ISP is managing the head network, that is the servers that provide the IPTV service, which is connected to the backbone network, distribution network, access network. They can even control the customer network, or at least have access to the customer network, and the set-top box, and that's it. Okay, and then we have the final user with the end user device. Well, the data is flowing from the head network to the final user through the thick black line, and the ISP is monitoring the network status. Here it's represented by the green line, so that they can monitor the status, the quality experience and quality of service status parameters in the network. So at the end of the head network, backbone, distribution, and any other place. They also are monitoring the application level quality experience at the head network and at the egress interface of the set-top box, and they can improve the quality experience by controlling the infrastructure, the backbone network, distribution network, and access network. So they assume, and this is most of times is the case for the IPTV service. They don't control, they don't change the configuration of the head network of the servers and of the customer network. They cannot control, and of the set-top box. They are just controlling the configuration of the backbone network, distribution network, and access network, because these are the components where they can really change the quality of service of the infrastructure. Okay, in this other work, they are focusing on the dash service. Here we have the servers that are providing the content using the dash infrastructure, and here we have the clients as we have seen before. So we have 3 clients here. Now they are proposing a joint. So in this case, the SP again is able to talk with the dash servers and with the clients, because they have proposed the installation of this video-aware controller, VAC, which is a company that is receiving information from the servers. You see here the video segment quality and rate information, and from the clients they are receiving information about the buffer levels. The orange arrows are representing the information received by the clients. Well, what this company is doing is to optimize, to understand what's the quality provided by the network and decide which are the best quality experience parameters. So this component is installed in the core routers in the network. So it's a component in the network infrastructure, and it receives information from the application level components, and it optimizes the configuration of the network and decides which are the best quality of service parameter. And specifically in this case, they are setting the maximum bit rate and granting bit rate, which are then fed into the access network components, and to optimize the configuration of the network. Okay, another approach is something that we are working with Arslan, and just mentioning that there is the possibility, even if it's not, we don't have real cases, so still it's the cooperation between OTTs and ISP is very limited. But one solution is to, anyway, at least from simulations and from the theoretical point of view, the OTTs and ISP may take advantage of a possible collaboration with them. So the OTTs may provide key information for the ISP to manage the quality experience at the network level, and the OTT may get a better quality of service for its own applications, for its own customers. So the idea is that the OTT here have the application parameters and user profiles. This information is collected by the QoE monitoring, which is interfaces with the network management at the SP side. And this one is monitoring also the quality of service at the network level and optimizing the configuration of the services. And the configuration will be done, the optimization will be done jointly, considering the OTT side and the SP side. So the optimal configuration then should be implemented by the SP and by the OTT, based on the optimization of the SP. Okay, so I just have some more to add about the SDN and NFV. So let's see how the SDN and NFV may change the perspectives with respect to what I said till now. I guess you know what SDN is. Just let me summarize very quickly. In the SDN framework, we have the data plane or forwarding plane, which is made by the physical devices, which have just the stupid function of forwarding one packet from one ingress interface to an egress interface. So it just these are just stupid physical devices which have been, let's say, made stupid by removing the intelligence, which is now given to a central device, which is operating at the control plane. So it means that it's a sort of centralization in the management of the network, in the operational of the network. So the physical device may not take decision on where to send a received packet. So unless this instruction is given by the control plane to the physical device. And at the network application orchestration and services, we do have the applications that are installed at this layer, and through the northbound interfaces, these instructions are given to the control plane and then through the southbound APIs to the physical devices. So installing this application here at the application level, we can create firewalls, we can create topology managers, we can create for example, also quality experience management modules at the application level. So here is the place where the new application management, QoE application management, network management services are installed and operating in the SDN framework. Together with NFV, SDN, we also have the NFV paradigm that has been proposed in the last few years. The difference with respect of NFV with respect to SDN is that NFV is leveraging on the idea that the different functions that are proposed by, that are currently implemented by different physical devices, as shown here on the left side of this picture, can now be implemented by only few types of devices. For example, standard high volume servers, standard high volume storage, and some high volume switch. So these three devices may be augmented with some functions, some applications that can be installed in the virtual machine of these devices. So these machines actually have some virtual virtualization layer and where some specific function can be installed in these devices. So if I wanted to have, for example, a one accelerator like this one, I can buy this Ethernet switch and I can install the relevant application. Or if I wanna, for example, to install a VoIP section border controller, then what I can do is to buy a standard volume server and install the relevant application, which is virtualized and creates a virtualized VoIP section border controller. So it's a different perspective of introducing a lot of software in the network equipment. So we have the bare hardware, the hardware which is without intelligence, and in case of SDN, they have a specific definition of what has to be done by the physical devices and what has to be done by the different two layers, control plane and application plane. In case of NFV, they're just saying, okay, we do have a virtualization of virtual machine virtualization layer in these physical devices, and in this virtualization layer we install the different applications depending on the needs of the operator. Okay, let me go to some considerations about that. So what changed with SDN? Well, what changes is that now we have a clear model of the switch, which works per flow, and we know exactly which are the metering functions that can be implemented by the switch. So the physical devices that are here, well, the standards have defined a clear behavior of this model. So we know exactly, okay, not exactly, but anyway, in a standardized way, which are the impact of each action performed by this device on the quality of service. And then from the quality of service, we can map to the quality experience. We have also clearly other information about the application that is deployed in the network. We have also standard model for the controller, which is working here. The controller is providing a network operating system, and so we know exactly which are the functions that can be implemented by the controller through the northbound APIs. This is again something that can really make a little bit of, let's say, make clear the environment where the application and network management function should work. Well, if you look at the application plane, is where actually our QoE related functionality should be located. So the place where we should develop our application for the management of quality experience, and then should be installed here. So we know that what exactly we can ask from the control plane and from the data plane, and based on this information, which already is standardized with respect to the past architecture. Now we know that at the application plane we can implement something for the modeling and management of quality experience. Well, this is also the place where OTTs and NSP can collaborate, because the application plane is deployed by the ISP, and the OTT will be interfacing with the application plane to collaborate and with the ISP. So it's a place, it's now introducing this softwareization in this procedure, then it becomes more flexible, and we can change over the time more quickly the way the quality experience is managed by the network, because it's just a matter of installing and upgrading the software here and in the servers that are deploying the application plane, implementing the application plane. And we may have also an OTT personalization, because for different OTTs, we may have different applications that are dealing with the quality experience. Okay, so there are already some proposals in this field, and for example, in this work, here you have the SDN switch, so the data plane. Here we have the controller, and on top of that we have the application layer, where this VQM is installed, and this one is the one that is collecting information, getting information from the SDN switch, passing through the SDN controller. They get information about the different flows and the status of the different flows. We have the estimation of quality experience, and then here the SDN video quality orchestrator is the one that manages the quality experience for the video services and decides which action should be taken, which again pass through the QoE estimator, and some new instructions are given to the SDN switch for that. In this other proposal, what the authors have proposed is the workflow of information, and from the application plane to the data plane again. So this is the QoE serve. They say that the QoE serve is an application which is installed by the ISP in the SDN framework, depending on the requirements of the OTT. So the OTT is interested in a given application, so it gives to the ISP a specific model, and this model is installed in this application. It's plug and play played in this application. So there are some parameters that should be monitored by the ISP. So this is an automatic process. Once this application is installed, then the ISP receives some request about what should be monitored, and it goes to this module because these requests are translated into requests to be sent to the network, and again this is sent back to the QoE server. The QoE server makes some computations and decides whether something should be changed in the network. Okay. Well, at this point, I wanted just to introduce the concept of QoE agent, which is in line with this process of softwareization of the networks. So till now, there is no any QoE related standardization activity. I mean, we have been talking about some proposals from the research community, industrial communities. The SDN and NFV now are in the process of being standardized. Actually, SDN has been already standardized, and NFV started later. But still, none of these have standardized any QoE specific function or interface. One of the first one, probably I have to say, the only one related to the network infrastructure with an eye on the quality experience is this QoE agent. The QoE agent has been standardized by Atzori. Actually, it's a very generic idea till now, so it's not really, it doesn't provide too many details. But still, it's a tentative to exploit this softwareization process to define how the quality experience should be monitored, and then after being monitored, managed by the network. So the QoE agent starts from considering that the quality experience can be measured in different layers. So it starts from the resource layer. And the resource layer is where the technical aspects of the network are located. So all the technical aspects are considering for what concern the network resources for the delivery of the service. Then on top of this, we have the application. So this is a layer. It means that we start from the bottom layer, the resource, till the user layer, which is the highest one. And the application layer is the one that considers the aspects related to the configuration of the application. The aspects related to the interface are considered in the third layer. So which physical equipment and interface are used by the user to interact with the application. Then also the context is considered in the fourth layer. Then the human factors are considered by the fifth layer. And but this is specifically considered the perceptual characteristics of the users. And then the other aspects related to the user when using the specific application are considered in the sixth layer. Well, starting from this layered approach, what they define is the QoE agent as an agent that implements a process measuring and actually rather than measuring, estimating the quality experience till a given layer. So we have a layer L, which is one of these 6 layers. Then to get the quality till a given layer, then we have to consider the quality till the previous layer. So these are the quality of the previous layer, which becomes an input to this layer. Then the process receives this input plus internal parameters, and then these are considered by the process at this layer to get to the output of this layer. The QL is the level, is the quality till a given layer. So we may consider, for example, the context. Then the context is receiving the outcome from the interface layer, and so the context is considering also the internal parameters, and then estimate the quality till this layer. Clearly, the quality experience is only something that comes out from the user layer. So when considering, once all the layers are considered, and let's say that the quality of resource 1 and till the application 1, we are only considering the quality of service. So quality of service is the outcome of the application layer. Okay, then they have defined the QoE agent as a software modules which communicates with the external world through the communication component. And the communication component then is storing the data at different layers for all the layers. And then the real logic of the QoE agent, the one that is implemented at the process for each given layer, is the controller. The controller takes different rules for the computation of the different layers from this other component, the layer component. So we have all the 6 layers here. Then we have the timer that is taking into account the timing information and persistent data that is used to store data, which is used by different running instance of the QoE agent. So the QoE agent is a very important part in the monitoring equipment. So the monitoring equipment, according to this view, will be implemented by this QoE agent with all the components. So the QoE agents in the NFV environment is just a virtualization of a probe, actually. This becomes a probe. This could be even, interfacing with other remote equipment. And this QoE agent will be currently implementing a virtual probe, because actually the monitoring, the measurement won't be done by the QoE agent, but will be done by a remote equipment. And then this QoE agent will be interfacing with QoE-aware application, the ones that I've been discussing so far, to the specific interface. And this is something that is possible thanks. Yes, Saman, I'm finishing. You're right. And then we have this application that could be installed at the application layer, interfacing with different monitoring equipment, implementing the QoE agents. Well, future challenge, very quickly. The future challenge, the first challenge is the net neutrality for sure. Because every time we talk about differentiating the services for the different users and different applications, we are incurring into the violation of the net neutrality. And it's nice to see in this picture how we can violate the net neutrality from low level to the high level. And, we know that the best thing is to just keep the internet as it is and provide just the best effort delivery. Then if we do some prioritization of some traffic, as we have discussed so far, then we are already violating a little bit the net neutrality. Then if we go ahead, we can do some load management, so change the way traffic is treated in different period of the day, of the year, or whatever, from any based on any principle. Then we can block illegal content. It's also violating the net neutrality. We can reduce the amount of bundle resources for a specific traffic. Or we can make a discrimination based on the content provider. There may be some agreements with different content provider, and we may even block some the content coming from a specific provider, for example, rival. And these are the major issues. Well, other issues, other future challenges for the quality experience aware management. We have a lack of interfaces between the different operators. So it's really important, if we wanted to really manage quality experiences, that all the chain of actors that are have a role in the management quality experience should be interactive with clear interfaces, and these are the OTTs, CDNs, and ASP. It's important to understand, to give a value to the quality experience for the provider, mostly for the ISP. Otherwise, if we don't give a value, and we cannot sell the quality experience to the ISP, so we need to really understand what's the value in terms of really value increase or revenue or reduction of cost for the ISP. We don't have interfaces to monitor the user status, and we need always to keep the customer in the loop, not always to consider the customer just the final consumer of the content of the service. We need to keep him or her in the loop, in the sense that the feedback and the behavior of the customer should be taken into account when managing the quality experience. We also need some clear open API at the application layer, so that every new application that is installed, for example, the SDN application plane, they can really interact in a seamless way, taking into account the quality of the service. Well, again, the APIs for telco for cooperating with the OTTs should be based on clear and innovative interfaces, and we may need to define for that a new semantic for the definition of the different concepts in the QoE area. Otherwise, the different actors won't understand each other, and so they may not be, understanding the same meaning, giving the same meaning to the same concept. Okay, I've put here some references that are mentioned in this. If everybody wants to get into some more details, then these references could help on that. Someone, I finished. So
thank you, Professor Atzori. So let's wait for the questions. Time for the questions. Still, we need to wait. I think Alex has a question. So.
okay, I see that Alex is still typing something. Well, we can even make questions speaking. I don't know if the others can speak or not. Anyway, you can send me also questions offline if you.
Exactly. I think in the case that no one has any question, we can conclude the session and they can ask you offline. I'm not sure if Alex is going to ask the question or not, but it seems that there is no one else. Okay, then let's conclude the session. Many thanks for a very interesting presentation for the course, and I think everyone will get back to you by asking the question. Again, thank you so much.
Okay, thank you for listening to me.